For the ones that had it emailed to them, should we print that out so that way we can follow along and like fill in what you're filling?
Well, what you could do instead of printing it out, you could just bring it up on your internet / your monitor, look at them. But of course, you're seeing mine here as well. And if you want to work it out on a scratch piece of paper or a notebook, for now. But yeah, if you want to print it out afterwards, if you got a printer, that's up to you. You're never going to turn it into me. And then what you're hoping to do is in about a week to 2 weeks, no longer, you will get your own copy. So you wouldn't even have to print it out because it's being shipped to you, or you're going to a drive-by and picking it up. Does that make sense, Zach? I think, Zach, you're asking that. Yeah. Okay, now when I look at this, this is P7. I'm going to look at my assignment schedule. Yeah, today's just preliminary, what's called P7. And this is all review from your intermediate algebra course that was prior to this. There's not enough room for me to work these out, so I'm going to do it on a separate piece of paper. But as you can see, the examples that I have, baby algebra 1 problem right here, baby. Could have been an algebra 1 for some of you, could be an algebra, like second half in algebra 1, or maybe an algebra 2 for some of you. That might be an algebra 2, maybe an algebra 1. I don't do this in algebra 1. When I say algebra 1, our 150 class, we don't do that. I do that in 156, 156, that's what we call it now. It used to be 155. So all the rest of them, really the only one that I know that I do for sure is this one now. And the rest of these are the advanced algebra in high school you might have gotten. So this is all review, nothing new. And let me find some scratch paper. The word distribute or the distributive property should be very familiar to you. And that's what I'm going to do first. So let's see, take the 2. This is multiplying, of course, and that would be 2x subtract 2. And then bring down the plus 3. And then I'm going to take the negative 3 and give it to both of those pieces. And of course, you know you're going to combine like terms. There are careless, easy mistakes. You know, your eyeballs go over here and you think that's 5 and you put plus 5. I mean, those are mistakes we all will make if we rush through it too fast, or if it's been 2 or 3 months since we've done any of the math. So we're going to check our answer at the end. Whatever I get mathematically, you always check it in the original. And sometimes the checking is harder, or you might make the mistake easier in the checking. So I don't always check my answers. I sometimes just trust the process. And this one here, I will check the answer. This is negative 2x subtract 3. And then I'm going to choose to bring everything to the left-hand side. So that means I'm adding 2x to both sides. Should give me 4x plus 1 is equal to negative 3. And you're going to move the 1 over here, the right-hand side. So that's subtracting 1. And then dividing by 4, you get x equals negative 1, maybe. I'm going to do a check over here. So before I box that, I'm going to at least check it. And as I said, we're going to check the original. And the original is 2. Now I'm going to plug in a negative 1 here. -1 there, -1 there. So I'm double checking yesterday in my pre-calculus math 27. I had that red thing down so close to the plus sign. I made a mistake and thought it was subtraction, and that I made that a subtraction. And then when I got down to the bottom, it didn't match up. So I knew I made a mistake somewhere. This could have been a wrong answer, or my check, of course, was wrong. I found where my mistake was. But that looks good. So Pemdas, you guys remember Pemdas, P-E-M-D-A-S. It's for order of operations. Got to do the parentheses first. No, you do not make that -4. That's not -4. Got to do the parentheses first. This is -4 plus 3 is supposed to be -1 plus or minus 0. That's gone. So, hey, looks good. That has not -1 here, and these -1s that have nothing to do with each other. That's just a kind of a fluke. What you're looking for is whatever happens here, is it true? If it's true, then that confirms that your answer is in fact -1. This could have easily, and at the end could have been like 12 equals 12 or 5 equals 5. So that's just a fluke. They happen to both be -1. But so -1 is the right answer. Someone in the other class, when I say the other class, I'm talking about math 27. They were talking about their technology and confirming it as well, an idea that the answer is -1. And we had a discussion about how you would do that. Because I have an equation right here, an equal sign, and if I went back into, not back, but if I went into my graphing feature, if the left-hand side of the equal sign right here was the first equation, so I'm going to put in 2 parentheses x subtract 1. I'm using a TI-84, 83, same button keystrokes. If you've never used a graphing calculator ever before, talk to Bonnie and I outside of class and we can help you, or there's YouTube videos, or there's lots of resources, and you'll pick that up probably pretty fast. I'm sure you will. So what I'm doing is I'm making the left-hand side the first graph. So y equals this. And then down here, I'll make the right-hand side be the same idea. 3 parentheses x plus 1. Okay, that looks right. Then what I'm going to do is I'm going to do zoom standard. So I'm going to graph both of them simultaneously. And what I'm looking for is where they touch, like where they're equal, where they touch. Looks like they touch right there. And the question is what's the x value right there? Don't look at that. That's the origin right there. So it looks like it's -1, but to make sure it's -1, there's a feature in your calculator which is called calc right there. So if I go second calc and I want to do the intersect right there. And then the feature is such that it says, hey, which one's the first? I know these are lines, not curves, but that's the calculator saying it. Okay, which one of these is the first? It doesn't matter because it's a first and a second. So I'm just going to hit enter again, and hit enter one more time with the question guess, and look for the x value. There it is, -1. So that's non-algebraically to check your work, or to find the answer, actually, to find your answer. So you might ask, the other person asked the same thing yesterday. Jeff, can I use my calculator on all these? No, I want to see the algebra for group quiz. Okay, so I'm going to rephrase my question and maybe even the answer. Jeff, can I use my calculator on the exam or daily quiz because, gosh, I know how to use my calculator and this looks cool. And then bubble, because it's multiple choice, bubble the right answer. Yeah, you actually could. Because I'm not looking for your process on the exam or the baby quiz. But for the homework, as well as the group quiz, I'm looking for the process that you understand it. Now the homework, I'm not grading it for correctness. I'm just looking to see if you've attempted the problem. So I'm really not looking at it in great detail. However, if you just send me an answer sheet for your homework, just answers, you're not going to get any credit at all. Most of these problems require some kind of supporting work for the homework. Most of them, not all of them, but most of them do. On the group quiz, I am definitely looking at your process. Definitely looking for that. So you want to do both ways just to be familiar, but on the exam, just bubble the right answer. It's good enough. Okay, so that's your first problem. Second problem. There's something called LCD. Back in algebra, LCD. So I'm going to approach it by trying to clear the fractions because I want to try to avoid the fractions. So here the lowest common denominator turns out to be the x plus 1. So LCD, what I'm going to do is I'm going to, in red, I'm going to put the x plus 1, what you do to one side, you do to the other. So everybody gets the x plus 1. And in doing so, makes the denominators go away. That's convenient. This one has to have the extra piece though. So gone, gone. And I've got 8x equals, okay, here, I'm just going to write down the 4 parentheses x plus 1. And then this one here is gone, gone. Now it looks like one of those baby problems. So I go 8x equals 4x plus 4, subtract 8. I guess I'm going to bring over the 4x over here. It's 4x equals what, negative 4? Ah, negative 1, negative 1 again. That's just, hey, everybody, every problem in the world is going to be x equals negative 1. Of course, that's not true, but. All right, and then I'll bet you a bunch of you, you do this on the multiple choice test and you'll say, well, it must be the answer. I'll box that because, you know, on number 2, on the multiple choice, you got A, you got B, you got C, you got D. Hey, letter B is x equals negative 1. I think I'll just bubble B, bubble B. Negative 1, sorry. Yeah, maybe A is equal to 1. Maybe C is equal to 0. Maybe D is equal to no solution. Now, why did I do that? Look at negative 1. If I check this now after the fact, you can't use it. If you plugged it back into this denominator, that's undefined. That's impossible. If I did 8 times negative 1 all over x minus 1. Well, x is negative 1. My mistake. Sorry. Negative 1 plus 1. Negative 1 plus 1. Then you get negative 8 over 0. And you'd be surprised on how many of my beginning algebra students, because it's been a while, will say a variety. Bonnie, I'd asked this yesterday, I think, to some of my algebra students. Hey, what do you think, without telling them what the answer is, what do you think the answer is there? And I got students saying 0, which is kind of the common one. It must be 0. And then I had some say negative 1, because they didn't know, or 1. Or interestingly enough, I had one student said infinity. And I said to that student, you know, it's not necessarily wrong. The words you guys are going to use is undefined. I mean, this for you guys, undefined for this piece, not the answer to problem number 2, but undefined is the result of that. Which means, by the way, for you guys, if that doesn't work, of course, the answer is, you know, this one's the answer for your problem. But the reason why I said to the person that infinity or negative infinity could be okay is because in calculus, we talk about that. So I asked her, well, how do you know, who told you that? Oh, my dad. Really? Yeah, when I was about 3 years old, he started talking about this thing that I go, wow, interesting. Why? True story, and she wasn't making it up. She says, my dad's a rocket scientist. I said, you mean literally he works for like NASA? Oh yeah, he used to work for NASA / whatever the company was. So that's beyond the scope of you guys saying that's infinity. Forget it. Undefined, can't work, no solution is the right answer. So be careful. You should check your answers probably, or just double check. Okay, number 3. All right, number 3. Now, I would think all of you should know those bars represent something, absolute value. My Math 27 class, I think, now Math 27, you guys did good by picking Math 25. Math 27, I had some students that didn't know what those bars were. And I said, you guys are in trouble. I told my Math 27 class yesterday, was it yesterday? No, Tuesday. So we'll find out how many show up today. Told them half of you are going to be gone. I was just plain old honest with them. Half of you are going to be gone by the end of the semester. I think I had 28 at the beginning, Bonnie. So I said, only 14 of you are going to remain somehow because they picked the class for the wrong reason. They want to get through the material fast so they can get onto calculus. I says, bad choice. I had one student that said, it's been 10 years since they've had anything. I says, I don't know. Let's talk afterwards. And which I did. And whether they're coming back or not, I offered them to come into this class, Math 25, if they really were hesitant. Anyway, that's absolute value. And so I bet you we know what without even doing the work, there are actually 2 answers. You guys can come up with the answer, right? There's an easy one and there's a kind of a harder one. Let's see, 9 minus 2 is, oh, gotta be 9. 9 minus 2 is 7. The other one is harder. Anybody know what the other one just by inspection is? You can just unmute and tell me what you think it might be. Say it again, America.
Sorry.
Oh, anybody have an answer? Not, okay, 9 works. There's another number that works.
-5.
Thank you. Yeah, you're right. Because if I check that, it'd be absolute value of -5, subtract 2, which is absolute value of -7, which is in fact is +7. So check. So sometimes they're just as easy just to check that. If they aren't, then there's an algebraic process. You can take a look at the author in the textbook on what that process is. And if you're stuck on it, Bonnie can help you, or I can help you as well. at the end of class today, the algebra on that. Okay, number four. All right, now if I look at number 4, similar absolute value problem. Now, I think what I'm going to do is move the 5 over first because it's not inside the absolute value. So I get absolute value of x plus 1 is equal to -2. And now, anybody have a observation or a statement, or can you come up with an answer or two?
Can absolute values not be negative?
Okay, there you go. Good observation. Absolute values can never be negative. So what kind of response would you box, do you think?
Like no solution?
Like you are absolutely right. So good job. You'd say no solution. Yep, nothing's going to work. Good job. Okay, the next one, number 5. Okay, should be recognizable. Anybody want to suggest a idea of how to go about solving this? Anybody want to suggest what they might remember? You can unmute the microphone and chime in. Anybody might suggest what kind of equation this is? I mean, there's a title to the equation.
Is it a quadratic?
Good for you. Gosh, are you the same person that responded the first time? I don't see you coming up on my screen, whoever responded.
Yeah, let me see if I can.
Anthony, okay. Yeah, quadratic, I like that, good job. It's a polynomial as well, but quadratic. You have an idea, Anthony, how you might want to consider?
You got to move, you have to move the x squared over to the other side so that you can graph it.
Okay, I'm going to take a couple things that you just said, and I'm going to modify it because you said 2 good things. Okay, you're going to move something to some side. I'm going to suggest you move it to the left-hand side. If you move it to the right-hand side, this becomes negative. It's a little more challenging-ish. Anyway, I'm going to move it to the left-hand side. Okay, so x squared subtract 8x. I'm also going to move this too, which is plus 15. And then what's left over here is 0. All right, now the other thing you said, which good idea, options, is to graph this. It isn't the only way to solve this, but he's saying if you went y equals x squared subtract 8x plus 15, if you graphed it, let's say we do, you know what picture you're going to get, Anthony?
It's going to be a U that's slightly up.
You know what the U, there's a word for the U picture.
Parabola?
Parabola. There you go. Good. It's going to be a parabola. And how do you know it's going to go up? Very good. You're on the right track.
Because your x squared is positive, it'll go up. If you moved it to the other side where it was negative, it would be upside down.
Fantastic. Good job. All right. So this will be a parabola. I expect that goes up. And then what are you looking for? Because I'm looking for answers here on the picture, Anthony. Do you remember what you would be looking at or for on the picture? Okay, let's look at the picture together. There are other ways of solving this, and we'll do that here in a moment. But let's look at the picture. Clear that. Clear that. I'll do Zoom standard again. Okay, so I get a picture.
Your answers are where it intersects the y-axis.
Man, you're spot on. Thank you. Thank you for all the correct answers and volunteering and giving it a try for your answers. Even if you were incorrect, it's okay. You're trying, and we would have come up with a strategy. But he's right. It's wherever they intersect. And you kind of look like it's 3-ish. 1, 2, 3, maybe 5, maybe 3 and 5, maybe. Anthony, you're on the roll. Did you ever use a graphing calculator in your previous class at all?
Yeah, the last class I took was like junior year of high school or something. That's the last time I've done math. So I did use it back then.
Did you use an 84 calculator? Do you remember?
Yeah, pretty sure that's it.
Okay, so I'm going to guide everybody on what I would do next, and this might ring a bell to you also. And do you own an 84 calculator or borrowed one, Anthony, right now?
Yeah, it's down in my truck.
Okay, so I'm going to go second, and there's this calc button right here. So everything blue for my calculator is blue words. So calc, and when you go down here, oh, there was the intersection that I did earlier. I go down here, they're called zeros. X-intercepts, if they're real, they're called zeros. So I'm going to press the number 2 or just toggle down here and hit 2. And now the calculator is prompting you with questions. When it says left bound, okay, I'm going to show you something. Here's the first answer that I'm looking for there. I put a red dot right there. I'm looking for that. Now it looks like it's 3. I get it, and 3 is the answer. But sometimes it looks like something on your calculator because it's kind of crap technology. See how pixely it is? It's not very good, picture-wise. They haven't improved it over 15 years. The images, the dots per square inch, the DPI, I guess. So I'm going to make sure that it's truly what I'm thinking it is, which is 3. Answer the question with left bound. Pick a number. I put a red felt pen here so your eyeballs will see what I'm doing. Pick a number to the left along the x-axis to the red dot. And don't get too close to that. Don't say 3. Don't do that. Pick something over here, kind of be generous. Like, how about -1? Or 1. I'll do 1. 1. Enter. And then what it does, it's kind of hard to see. It puts a flag right there. And the flag is actually pointing this direction. It's hard to see. Here, let me do this again and I'll do it at -1. So I'm going to do -1. Okay. See, you see the flag and it's going to look to the right from here, from the left, bound. Now it says right bound, so pick a number over here like 8. Now it's going to look in between, and it's going to find, in this case, it's going to find one of these. Now, because there's 2 zeros, 2 x-intercepts, I'm not sure which one it'll find right now because there's 2 of them. It'll find one of them. If I want to make sure I find this one, then you want to put your right bound so it doesn't capture both of them. So I'm going to hit enter and see which one it finds anyway. Oh, it did find the 5. See, it didn't find the red one, it found that one. So now I'm going to go over here and say, well, shoot, x equals 5 is one of the answers. It looks like it. Now I got to find the other one just to make sure. So second calc 0. Left bound, I'll still pick -1. All right, now right bound, instead of way over here, I'm going to pick, it looks like 4 instead. Hit enter. And sure enough, I'll erase my red dot. There's the cursor blinking. Yep, it's 3. Anybody remember, a little side note, remember what they call the ordered pair, the place right there at the bottom? Anybody remember that on a parabola?
Isn't that the origin?
No, the origin is sitting over here. What do they call it? The bottom, in this case, the bottom of the parabola.
Is it the midpoint?
Okay, good try. It's not the midpoint. It kind of looks like you would call it the midpoint, but that's not the phrase we would use.
Vertex?
There you go. That's called the vertex. Very good. And more about that, again, in this course later on, when we do more about what's called the quadratics. We'll graph those, or parabolas. So that's just a little side note. We'll come back to that vocabulary later in the course. All right, let's go back to this. Let's say it says by any method. We did it by graphing. Let's say instead of the method by graphing, you want to solve it by algebra. How might I solve this? I know the answers are this. Solve this by algebra. Anybody have an idea?
Is you got to find a number that multiplies into 15 and adds to -8.
Okay, okay, good. I heard 2 people respond. I heard 1 person say factor in the background. That's a great idea. And I heard the other person who gave me a little bit more of a description, which sounds like completing the square. So I'm going to write some of these methods, algebra methods down. I can think of 3 of them. So factor is 1. If you can, in fact, factor. Complete the square. Complete the square is another one. And there is one more, which is called the quadratic formula. All of you should have seen that as well at some point in time. You just needed to be reminded about it. So I'm going to wait on the quadratic formula because there's another one coming up next. I'm never going to do complete the square personally. There's easier ways of doing it. But some of you, which I don't know, Dylan, were you the one that said complete the square? Can't remember if that was Dylan's voice.
Can't remember the names of methods.
Yeah, so Dylan, if you like complete the square, I'm good with that, no problem. And then who said factor earlier?
Oh, I did.
Okay, Camden, let's do the factoring on this.
Sure.
How might that look when you factored it?
Well, you get 2 numbers that multiply to 15, add to -8, and you just get x minus 3 and then x minus 5. And then you solve for those x's and you get x equals 3, x equals 5.
Good job.
Thank you.
Oop, minus, you did say minus. This was wrong with the plus. Minus 5. Okay, this is a baby algebra factor problem. Everybody in my beginning algebra will learn or need to know how to do this, and quickly. So good job on that. And then also you go x subtract 3 equals 0. And here you go x subtract 5 equals 0. So you're right, x equals 3, x equals 5, which exactly is those guys there. Good. I'm glad I'm hearing a few students out there that are feeling somewhat confident about what's going on. So it's not maybe thinking about the homework so far. At least your first homework assignment is doable, because these are the kinds of problems that you'll be seeing in P7. Okay, the next problem, number 6, is similar. So Camden, your factoring technique will not work here because
Yeah.
factors of this is 1 and 5. You can't make a 2.
Yeah, I figured.
Dylan, his strategy will work, and which I'm not going to do that strategy because it's, I don't know, there's so much better ways of doing it. Earlier, someone had suggested the graphing. Now, when you graph this, you're still going to get a parabola that opens up because there's a positive right there. And you will get 2 x-intercepts, I believe. However, when you do the zoom, not zoom, when you do that second calc and you're looking for the x-intercepts, you're going to get a decimal approximation. It won't be exact. So if you're asked for exact answers and your calculator on the graphing doesn't give it to you, you have to come up with another algebraic way of doing it. And so out of the choices over here, that'll do it. That'll take care of it. The quadratic formula will handle it, and your calculator won't. So here you're stuck with doing the algebra, and the quadratic formula looks like this. You guys remember this? Okay, there's an A, B, and C. Remember the A, B, and C? Anybody remember what the A, where you find the A? Or what is the A? And the B and the C?
The leading coefficient.
Of the x squared.
Right, it's the coefficients, and so it has to be in descending order. So what is the coefficient of the x squared?
1.
Correct. This is -2, and this is +5. So the formula, this is the formula, just to remind you, is the opposite of b plus minus square root. See, now it's starting to sound familiar for you, a number of you. B squared subtract 4ac. Okay, now it's all over what? Anybody remember what the
2a.
2a. Now, is the 2a just right here?
It's across the whole formula.
Thank you very much. It's across the whole numerator. Yeah, good. Just got to be fair, careful. Now, you also have to be careful in replacing all the variable values, especially if it's -2 in this case. That -2 sits right here. That negative right there is still sitting there. So I'm going to write it as -2 because the b is -2 plus minus square root. Now, again, be careful because if you just put -2 like this with a power of 2, that's not right. Mathematically, that's not right. You know what -2 squared answer is? Anybody have that?
-4.
Exactly. Right, -4. But I don't, this is supposed to be take -2, the whole thing, and square the whole thing. It should be this way. That's the right way to write it, I guess I'm going to call it. So in general, that's correct just by writing it out, but I need to have written it this way so I get the +4 that I intended for it to be. All right, so -4, a is 1, c is 5, and that's all over 2 times 1. And so then you got x equals +2 plus minus square root. What is this, 4? Subtract 20 all over 2. Okay, now I'm stopping there for a moment. Okay, I'm observing something that feels uncomfortable. Anybody know what I'm thinking about? What's happening here?
The negative square root.
Okay, I'm going to speak it differently. The square root of a negative. When you said negative square root, it's like a negative square root. It was telling me that the negative's outside. But I know what you meant. So the square root of a negative 16, Laura, do you know what, did you have a class that addressed what that would be? Remember any class before that? And if not, that's okay. You know what that would be, Laura, at all?
No.
Okay, fair enough. Anybody have an idea? Have you ever seen square root of negative 16 and know what?
Does that give you two answers, -4 and +4?
Okay, not quite, but good job. Okay.
Yeah, you need I.
Okay, a couple of you said imaginary. Okay, so some of you that said imaginary, you've had a little previous information, more than I expect. That's okay. All the rest of you, we will be looking at what's called imaginary answers in this course. I'll have a whole section on it. Sometimes they call them complex answers or imaginary answers. It has a letter I that's involved there, but don't worry about it today. You're not responsible for it today. If you ever came up with something like this, by the way, I heard someone say ±4. If you take the square root of negative 16 in your calculator, here's what the calculator is going to tell you. It's not 4, it's not -4. It's like, it's not real, which means imaginary. Great, you can't see it. Imaginary, can't see it. Complex sounds like it's really hard. It's not. Imaginary numbers, you can see them, I'll show you, and they're really not hard, but that's later on in chapter 2. So what are you going to do with a problem like this? You're going to say like this, no, like right here in red, no real solutions. And the book might have a different phrase for that too. You'll have to take a look and see what the author does.
I have a question.
Yes, sir.
Where did the A equals 1 come from?
Thank you.
I'm confused about that.
Thank you. Thanks for asking the question. So in quadratic formula world, A is the numerical coefficient from your x squared term. So this is your A, and it was just hidden there. You rarely ever see a 1 sitting there as a numerical coefficient. It's assumed to be 1. And then B is right here. And B, you have to capture the sign as well. And then C is +5. Good question, because if you didn't quite see that or remember it, then others did not either.
Thank you.
Yeah. Okay. Okay, I'm going to do one more, and then I'll leave number 8 for you to think about. I'll do number 7, and I think I've got enough for you to do your homework for this weekend. So, number 7. Okay, this again, I've given this absolutely in my beginning algebra class. And so that's the first time that students will see it. Any idea, anybody have an idea how to work through this one? If you remember?
Square it.
Yes, a couple of you said it, square it. Good, good, good. All right, so here we go. I'm going to put a power here, shove these guys in. And square root, they eliminate each other. They're reverse operations. So basically you're left with, okay, here's a question for guys, see if you remember vocabulary. Anybody remember the what I just circled? There's that garbage underneath the radical sign. You call it something. The stuff under the say again, I think someone said it right.
The Radicand.
Exactly, good job. And do you know, I know that's a number 2 sitting right there. It's invisible. But you know what the numbers that sit there are called in general? There's a word for the numbers that sit there. So this is called the Radicand. Radicand, that's vocabulary. That's called the radical sign. What's the number 2 phrase we use? Starts with letter I.
Is it the index?
Excellent. Very good. It's not used a lot, but if you ask any instructor, I'll bet you they've said, oh yeah, I've used that. The index is 2. Usually they'll just go and say, hey, the square root of whatever. They won't emphasize it all that much. Anyway, that's the index. The index is where the number is, the number in the cusp. The Radicand's the garbage that's underneath. And here we go. So what I'm left with here is the Radicand. 1 you subtract 8x equals x squared. Hey, we're back to a quadratic, aren't we? Right back to a quadratic. So I'm going to choose to move both of those guys over here so it keeps my quadratic with a leading coefficient of positive. I'm going to choose to make this 0 equals x squared plus 8x, subtract 20, and then see if it factors, because that'll be the easiest way of approaching this. Let's see, 20. 2 and 10, I think that works. 2 and 10. 2 and 10. I think that might be it. So what I'm going to do, I'm going to try it. Factor x, 2, 10 to give me positive 8. That has to be a positive. That's a negative. Solve this, you'll end up with x equals 2. Solve this, this is x equals negative 10. If this was a multiple choice problem on your exam or the little baby quiz, letter A, this might be letter A for your choice. And you might believe that that might be your bubbled. However, guess what? One of them doesn't work. Here, think about it, this negative 10. If I put negative 10 right there, how can a square root of anything become negative 10? That's impossible. Just like the absolute value can't be negative. You can't have the output for us. It's called the principal square root. Can only be positive. This will not work. This one will be the only one that works. So you got to be careful with these problems in P7. You should check. Okay, I can tell you the ones to check. The square roots and the fractions. Those really are the 2 that you need to check, because you'll probably pick up what they call extraneous roots, extraneous zeros. So just be careful.